So hey everyone, hope you're all doing well. So most of us know about Google's AI image generation model called NanoBanana. So NanoBanana is an amazing model where we can just describe what type of image we want and just in text prompts. And NanoBanana is going to give us an amazing image, infographics, block diagrams, and so on, right? And recently, Google, along with researchers from Peking University, have come out with another amazing model, or rather a paper. So this is called PaperBanana. And what it tries to do is it tries to generate images that are usually used in scientific papers, research papers, and so on. And that's something that really piqued my interest. So let's go take a look at PaperBanana. So this is PaperBanana's project page. So as you can see, it says PaperBanana automating academic illustration for AI scientists. I really like the name AI scientists. That kind of tries to indicate something like scientists who are going to be using AI in the near future. So as you can see, most of the authors are either from Google or Peking University, so probably some kind of a collaboration between the two. And so here we have the archive, the code, as well as the Twitter for all of this. So what we see here is something called methodology diagrams and the statistical plots. So it says examples of methodology diagrams and statistical plots generated by PaperBanana, which show the potential of automating the generation of academic illustration. So what methodology diagrams means is that, so I've written a few papers. So most of the papers have like some standard sections like abstract, introduction, related work, and after related work, usually like you have methodology. So methodology tries to kind of put together the whole paper in a block schematic end to end. And that one diagram, if we just see, that could more or less tell the whole thing what the paper is actually proposing. For most scientific domains, this is how it is. And that's a very important part of the paper because that kind of tells everything about it. And the other parts is, of course, also the statistical plots and the results. So this usually changes from domain to domain. Some domains you have visual results, some domain you have statistical results. But either way, they're all important for these. So what interestingly we see here is that you have both methodology diagrams as well as statistical results. And this looks, frankly, this looks pretty amazing, right? Like you can see if all of these are generated by PaperBanana, and that's really amazing. So it says, despite rapid advances in autonomous AI scientists powered by language models, generating publication-ready illustrations remains a labor-intensive bottleneck. That's very true. I myself have gone through this many times, is that you need to really be spend a lot of time, sometimes hours, days, to kind of come out with nice diagrams, illustrative diagrams. And with AI, we see that like there are lots of ways in which you can prompt and hit the diagrams in a decent way. NanoBanana does that. Claude, you can go to Claude and ask. I myself had done a video. We'll try to put that up, where you could generate block diagrams just by prompting it, and then using either draw.io or some other tools, Mermaid, to kind of further refine it. But this is pretty amazing because that one would still need a lot of work, but this one seems like the quality of the diagrams that have come out is pretty amazing. So it says powered by the state-of-the-art VLMs and image generation, PaperBanana orchestrates specialized agents. So that's really nice. So it's an agentic framework. So it has a bunch of tools. I'm guessing like agentic tools, and this PaperBanana is going to take the input and then kind of create a plan, and then now that's what agentic framework is all about, and then go and use those tools to kind of create the task that they want. To rigorously evaluate, we introduced PaperBananaBench, comprising 292 test cases. So that's pretty nice as well. right? Illustrating, like covering papers from numerous 2025 publications and so on. So let's go a little bit more into the project page. So it says method overview. We propose PaperBanana, a reference to an agentic framework for automated academic illustrations. So it has 5 specialized agents: a retriever agent, a planner agent, a stylist agent. That's really nice. Um, in my time, I was not giving too much importance to stylist, but today with AI, if stylization is possible, why not? Definitely, who would not want to see pretty diagrams, right? So visualizer and critic. So instead of going, let's just instead of going too detailed into what each of them are, let's first see. Retriever agent identifies relevant reference examples to guide downstream agents. So possibly it has a bunch of examples. Planner agents acts as at the cognitive core, translating context into detailed textual descriptions. So in agentic framework, a planner is usually the second step. It's like you take in the input and convert it into a plan, and then that is sent to a bunch of tools, and then the execution is done. That's what the usual agentic framework is. And then you have a stylist agents ensures adherence to academic aesthetic standards by synthesizing guidelines from references. So this is really interesting. I honestly don't know exactly what it's trying to do. This is something which I've not usually done. I'm guessing that from what it describes, what the description is here, um, it tries to see other papers and see what the styles are and tries to like generate similar images, right? Something like that. Visualizer agent transforms textual descriptions into visual output or executable code. This is interesting. Critic agent inspects generated images plots against the source to provide feedback for refinement. So you can see that. So you have the inputs, the source context, and I wonder what the communication intent is. That's something interesting. So you have a retriever agent which takes it from a reference set, and then you have some examples, a database of examples, and then a planner agent, initial description. So it tries to plan and give out an initial description, and then a stylist agents, and then this is the first phase, the planning phase. And then we have the iterative refinement loop. This is becoming very common in most agentic papers these days. Is that you have this and wherein you first generate an image, then it goes to a critic, and then it tries to like visualize. Then you kind of do this repeatedly. Here they only do it 3 times, which is interesting. And then after that, that's what it says. And then you have the final illustration. So this reminds me of generator adversarial networks or GANs, where you have the generator, the discriminator, but here it's like I think the names have changed, but more or less the technology, I mean the method used seems very similar. And but GANs, like I mean, a few years of research were only full of GANs, and so much research has been done. So it's interesting that the papers that going to come out these days, if it's going to use iterative refinement loop, all of those could kind of be translated to this, and then you may be getting more and more papers like this. So interesting anyways, yeah. So let's see, and then they have benchmark construction, and then let me go maybe a little bit down. Experimental results, so they compare it with GPT Image 1.5 NanoBanana Pro. That's interesting. NanoBanana Pro is really good. I've tried it a few times, and it's really good. And then ShoeShot NanoBanana Pro. So, and they also have some qualitative metrics to kind of measure, like faithfulness, consciousness, readability, aesthetic, and overall. So overall, combining all these 4. So that's, or maybe like just doing an overall picture. And so these are all qualitative metrics. So qualitative metrics are always good to kind of do because that I mean, at the end of the day, it's a human who's consuming this, right? It's good to kind of see how I mean what the qualitative metrics are, And interestingly, they also have a human in as one of the, what if a human generates these images, and what would those metrics be? So that's also been done. I'm guessing that since it's a human, they're just giving it like 50. That's the best or something like that, or even or like by chance. So let's go further down. Original, enhanced, and so this is nice to see. This was the original one, and I think this is probably the styler, which enhances the styler visualizer, which does that. And a few more case studies. This is interesting. Case study of diagram generation. So this was the one which was done, but these two are the ones which were done by a human for the same similar prompt or similar method. And this is done by PaperBanana Pro. So again, think about the fact that it would have taken quite a while for the human to do these things, whereas PaperBanana Pro or PaperBanana, I'm guessing it's going to be just like a less than a minute or something like that. Definitely for a human, it would have been more than a minute for sure. So interestingly, we can see that how the PaperBanana's results seems closer. This one seems closer to the human. This one seems nice to look at because PaperBanana is okay, but it's not very colored. It looks a little dull. Of course, you could also further prompt PaperBanana Pro to make it appealing and things like that. I usually do that. So here's some style enhanced prompts. So this one is original diagrams, and this you can enhance the style. It's interesting. I can think of this as a style transfer in block diagrams or diagrams. That's very interesting to see that happening. It's amazing to see how people innovate and come out with these really amazing the methods. I'm reminded of my favorite, some of my favorite papers, CycleGAN and I think StarGAN and maybe even Pix2Pix. Those were really not just groundbreaking methods, but those are even like really innovative and creative methods. So it's amazing to see how researchers constantly innovate and be creative in what they do. So, and here are just some plots. So I think IMG should be just image, and then this is coding. I'm not exactly sure what the difference is. Case study of visualizing statistical plots with code and image generation. So I think one of it is just pure image generation like PaperBanana, and the other one is like generates the code and then kind of executes that to plot it. Because I mean, you could do all of this using matplotlib and with Python code. So that's what it probably compares, and it's really interesting. I myself have tried image generation as image many times without the code, and it was interesting to see how these images are generated. Probably some code is executed in the back end, but it's nice to see. And it's also great to see failure cases. No matter how good your method is, how much your paper is, it's always good if failure cases are discussed in a paper. That actually adds more confidence and validity to the paper rather than people thinking it may be a weakness. So that's nice. I'm not going to go in detail over this. So really amazing. This is a PaperBanana. I would really love to try this out sometime. And what's really interesting is that I think this the code is not even out yet. So they have a link to the code, but I believe the code is not even out yet. If I go to the GitHub repository here, and it already has 3,000 stars. So this is just an initial repository, right? Or they just initialize the repository. And even without any code, they said our code and data set will be released in 2 weeks they're using a Creative Commons license. It already has 3,000 stars. That's insane. That you can see how much people are waiting to test this out. And another interesting thing which I came across, maybe I'll try to cover it a little bit more detail in one of the following videos, is that I didn't go through this in detail like how I did for the project page. So this is actually the That didn't be like that. Let me just go and go to the paper. So this is actually the paper, which is an archive, and this is 49 pages. That's a lot, and it's very nicely written. Probably they use the same images, but that's really long. And but I can see that most, at least, only 12 pages are actually like the actual paper. Mostly the other ones are going to be appendix and illustration or whatever. Yeah, quite a lot of references. But yeah, maybe in another video we'll see if you can go through the paper, or maybe even decode the paper using some AI methods. So that's it for now. I think I'm really eagerly waiting to try PaperBanana once the code is out. So hope they release it real soon. So I would like to try PaperBanana once the code is out. So until then, see you next time.